They lie to you. It's all completely fake. I'm here to tell you something you probably already suspect. In this video, we're exposing the biggest lies about space that have ever been told to you. How can something as brutal and violent as explosion be soundless? What would actually happen if you opened an airlock and spilled oxygen into the void? In the absolute stillness, with no gravity or wind, would it form a stable, breathable cloud? Then, we'll crack the cosmic communication code. Finally, we'll solve the greatest visual mystery. Why is our sky a brilliant blue, while space is an endless black? And why stars' glittering light is showing you a past that may no longer exist? The thrilling soundtrack of interstellar war is pure Hollywood magic. If you were actually floating in the vacuum of space during one of those epic dogfights, you wouldn't hear a thing. No engine roars, no laser zaps, no planet-shattering kabooms, just total, mind-bending silence. It sounds crazy, right? How can something so violent be so utterly quiet? Let's break it down. It all comes down to one simple fact. Sound needs stuff to travel through. Let's do a quick thought experiment. Imagine you're at a rock concert, and the crowd starts a massive wave. That wave travels around the stadium because one person after another stands up and sits down. The wave is carried by the people. Now, imagine trying to start that wave in an empty stadium. It's impossible. There's nothing to carry it. Sound works exactly the same way. It's a pressure wave, a vibration, that moves by bumping molecules into each other. On Earth, it bumps through the air molecules around us. Underwater, it bumps through water molecules. Through a wall, it bumps through the solid material. But space? Space is a near-perfect vacuum. It's the ultimate empty stadium. There are no molecules, no atoms, no stuff to bump into each other and carry the vibration to your ear. That's the secret. No air, no sound. It's that simple. This is also the answer to a question you might be having. But wait, I hear astronauts talking on their spacewalks. And you're right, you do. But you're not hearing their voices travel through space. You're hearing a radio signal. Here's how it works. An astronaut speaks into their microphone inside their helmet. The sound vibrates through the air in the helmet. The radio in their suit converts those sound vibrations into an electromagnetic signal, which, unlike sound, can travel through a vacuum. More on that later. That signal beams down to Earth, where your TV or radio converts it back into sound vibrations in the air of your living room. So, if you were floating right next to an astronaut during a spacewalk, you wouldn't hear them speak, even if they were screaming right at you. You'd just see their lips moving behind the visor, surrounded by the most profound silence in the universe. The only sound you'd hear would be the ones coming from inside your own body. Your heartbeat, your breath, and the blood rushing in your ears. That's it. Everything else is a Hollywood fantasy. All right, we're floating in our totally silent space movie. But this creates a huge puzzle. If sound can't travel through the vacuum, what can? How do we get pictures from the James Webb telescope or talk to astronauts on the moon? The answer is right there in the spoiler I dropped earlier, the electromagnetic signal. Think of it this way. Sound is a needy traveler. It has to hitch a ride on molecules like air or water. No molecules? It goes nowhere. But an electromagnetic signal, which includes everything from radio waves to visible light to X-rays, is an independent traveler. It doesn't need a medium. It is its own ride. A text message is a perfect example. It zips from your phone to a cell tower through the empty space between them as an invisible signal. It doesn't need air to carry it. So how does this work in space? Let's take a stunning picture from the James Webb Space Telescope. The telescope captures the light, which is itself an electromagnetic wave, from a distant nebula. That image is converted into digital data, a string of ones and zeros. This data is then encoded onto a radio wave, another type of electromagnetic wave, and beamed back to Earth. The radio wave flies perfectly through the vacuum of space at the speed of light. We catch it with a giant dish antenna, decode the ones and zeros, and rebuild the jaw-dropping image on our screens. Your voice getting beamed from a spacesuit uses the exact same principle. The sound itself never travels through space. Instead, it's converted into data, placed on a radio wave, and sent to Earth to be played through a speaker. The silence of space isn't a barrier for information. It's just a different highway. So now we understand the silence and how data crosses the void. This brings us to a crucial question. What about the air we breathe? If there's no gravity or wind in space, would a sprayed cloud of oxygen just hang there, forming a permanent, breathable bubble? It sounds cool, but it's another lie. Let's do a quick experiment. Imagine you have a spray can of air freshener here on Earth. You press the nozzle, and a fine mist puffs out, hanging in the air for a moment before slowly drifting down and fading away. Why? Because the gas is fighting its way through our thick atmosphere, and gravity is pulling the particles down. Now, let's take that same can into the vacuum of space. What happens when you open the valve? The gas wouldn't puff out. It would explode out. And then it would be gone. Instantly. Here's why. And it's the single most important rule about stuff in space. Everything is always trying to spread out forever. This is thanks to a concept called kinetic theory. Think of a gas, like the oxygen in our tank, as a zillion tiny hyper-caffeinated billiard balls, all zipping around at insane speeds and constantly bouncing off each other. On Earth, the weight of our entire atmosphere is pushing down, keeping these balls mostly contained and bunched up. But in the pure vacuum of space, there is nothing pushing back. There is nothing to bounce into. The moment you open a container, those zillion billiard balls get their ultimate freedom. With no air resistance and no gravity to hold them down, they just fly. They expand in all directions at incredible speeds, their molecules spreading out in an ever-thinning cloud until they are, for all practical purposes, completely and utterly gone. They don't hang around. They don't form a nice, visible cloud. They become an invisible, diffuse part of the interstellar void. This is also why you can't have a pocket of air in space. There's no container to hold it. The moment it's exposed, the frantic motion of the molecules forces them to expand into the infinite emptiness. This relentless expansion is a key part of what makes space so lethal. It's not just that there's no air to breathe out there. It's that the air inside you is desperate to get out there. Your lungs, which are a nice, high-pressure container on Earth, suddenly become a liability. The vacuum is the ultimate expression of freedom for every single molecule, and it will tear your body apart to achieve it. But this violent emptiness does more than just kill. It also transforms how we see the universe itself. The very same lack of atmosphere that makes space deadly is also what makes it so breathtakingly black and its stars so sharp. On a clear day, our sky is a brilliant, comforting blue. But the moment you leave our planet, that blue vanishes, replaced by an endless, inky blackness dotted with sharp, unblinking stars. So, what's going on? Why is the sky blue on Earth but space is black? The answer is all about what light has to travel through. Sunlight might look white, but it's actually a rainbow of all colors combined. Each color has its own personality, specifically, its own wavelength. Blue light has very short, quick waves, while red light has long, lazy ones. Our atmosphere is filled with incredibly tiny molecules of gas. When sunlight enters this atmosphere, it bumps into these molecules. The long, calm red waves mostly ignore these tiny obstacles and pass straight through. but the short, energetic blue waves get scattered like hyperactive pinballs, bouncing off the molecules and spreading across the entire sky in every direction. No matter where you look, your eyes are being hit by this scattered blue light. So the sky itself appears to be blue. It's not a blue ceiling, it's a blue glow created by the air itself. Now, let's take that same sunlight and send it into space. There's no air, no gas molecules, nothing for the light to bounce off of. With nothing to scatter it, the light from the sun travels in a perfectly straight line. If you look directly at the sun, it's blindingly bright. But if you look away from the sun, there are no molecules to bounce any light, blue or otherwise, into your eyes. You see nothing. Just the pure, uninterrupted blackness of the universe. The blackness of space is the true color of the cosmos. It's the color of nothing. It's what you see when there's nothing along the path of the light to illuminate. This leads us to the final piece, the stars. If space is so black, why do we see stars at all? Because they are their own light bulbs. Stars like our sun are gigantic fusion reactors, constantly turning hydrogen into helium in their cores. This process releases a staggering amount of energy, which includes visible light. That light then does exactly what we described. It travels in a straight line through the vacuum of space for years, centuries, or millennia, until a tiny fraction of it finally enters your eye. And here's the truly mind-bending part. You are looking back in time. The star you see tonight might be 100 light years away, meaning the light left its surface 100 years ago. You are seeing what it looked like a century ago. For all we know, that star may have exploded or died long before you were even born, but its final light hasn't reached us yet. We see its ghost, still shining in our sky. You aren't seeing a star reflecting light. You are seeing the star's own historical broadcast, a tiny, brilliant pinpoint of light that has crossed the cosmic dark to reach you. The reason they don't twinkle in space, like they do from Earth, is because there's no atmosphere to distort their steady, unwavering light. So the view from space isn't just a darker version of the view from Earth. It's the universe's true face, a vast, black canvas where light only travels from the source directly to your eye, revealing a brilliant, silent, and untwinkling sea of suns, many of which are cosmic memories, telling their stories long after the story has ended. So, let's lay out the universe's real rulebook one final time. Space is silent not because it's peaceful, but because it's empty. The vacuum is a freedom so absolute that it will tear the very air from your lungs, not with force, but with absence. The light from stars is a ghost, a historical document showing you a past that may be long gone. And the stunning blackness above is the true color of nothing. Every one of these rules is unforgiving. There is no compromise. To survive, we must rebel against this indifference with every tool we have. Our spacesuits are miniature mobile atmospheres. Our radios are bridges across the silent void. Our spacecraft are tiny, warm bubbles of Earth. We don't conquer space, we endure it. Our ability to live out there is a testament not to our dominance, but to our ingenuity and our stubborn refusal to be confined to our planetary cradle. This isn't just science. This is the universe's real rule book, and it's more bizarre and beautiful than any fiction. If this journey into the true nature of the cosmos has blown your mind, there's plenty more where that came from. Subscribe to the channel and hit the bell icon so you don't miss our next exploration. By subscribing, you're telling the algorithm that you love deep dives into the universe's greatest mysteries. Thanks for watching, and we'll see you in the next video.